Hi, I'm Claude Gauguin, Technical Engineer with the National Precast Concrete Association, and today I'm here with Sam Lines from Concrete Sealants to talk about vacuum testing. Sam has performed countless amounts of vacuum tests throughout his career, and he's here today to help us guide us through the process. Thanks for being here, Sam.
My pleasure, Claude.
All right, so the first thing I want to ask you is, can you tell us what a vacuum test is and how does it work?
Well, Claude, a vacuum test is the process by taking the air out of a tank so that we can compare the structural integrity and the water tightness of that tank. You see, the barometric pressure right now is about 30 inches of mercury, and we're going to draw 4 inches of mercury, or a negative 4 inches, out of this tank. So that's going to make the relative barometric pressure inside the tank 26 inches of mercury. By doing that, we're going to be able to see that the tank both can withstand water tightness and structural integrity. The structural component of this is going to be applying 72 pounds per square foot of force for every inch of mercury that we draw down.
Thanks, Sam. So today we're dealing with a 1,000-gallon precast concrete septic tank, mid-seam, 2-compartment. We have 2 access holes on top, we have 3 gasketed inlets, and 1 gasketed outlet. So Sam, let's start with safety. What type of precautions do we need to take when we do a vacuum test?
Well, Claude, first and foremost, we need to make sure we have our hard hat and safety glasses on. We need to make sure that we're doing this test in an environment where there aren't a lot of other people around, because if something goes wrong, then there could be debris flying around and it could hurt somebody. We also need to make sure that there is nobody inside the tank or on top of the tank while the test is being performed.
Okay, Sam, so can you talk to us a little bit about any precautions we need to take if we ever do this test in cold weather?
Well, Claude, you see, the atmosphere contains moisture. So as you're doing a vacuum test with air, as that air passes through, if the temperature is below 32 degrees Fahrenheit, that moisture inside the air will freeze. And inside of the ports for the air compressor, or even the vacuum generator we use, you could have freezing particles that would clog those ports. So we would really recommend that this test not be done in temperatures below freezing.
Great advice, Sam. So let's talk about the equipment.
Okay, Claude. Well, we can draw a vacuum from a number of different places on this particular tank. The first thing I want to talk about are the openings on the top. We can draw a vacuum through the openings on the top as long as we have the equipment to do that. We would need a plate that has an access hole that we can plug into. If the plate is used that does not have a method of sealing, then we would need to have that plate sealed on top of the tank. But today, Claude, we're going to actually be drawing a vacuum through a different place. We're going to draw a vacuum through one of the inlet holes. This is a booted gasket. So today we're going to attach to one of the booted gaskets with this assembly right here. You can see this is your basic assembly, 4-inch PVC pipe. It's got some attachments that are made to this so that we can draw a vacuum. The first thing we're going to do is make sure that the pipe is tight with the hose clamp so that the boot is sealed. The next thing we're going to do is we're going to take our vacuum generating pump. This is a Venturi pump, and we're going to hook our Venturi pump to this assembly. After we do that, the next thing we're going to do is take our air line, and we're going to plug our air line into the vacuum generating assembly. Then, Claude, to be able to measure the vacuum inside the tank, we need to be attached to gauges. We're going to attach this small hose to the port here so that we can actually record the pressures that we're reading inside the tank.
Okay.
You can see right here, we have 2 gauges. Each one of these gauges measures 0 to 10 inches of mercury. We use 2 gauges so that if one gauge is incorrect, we can make sure with the other gauge that it's calibrated with each other.
So ASTM C1227 requires that this test be run for 5 minutes. How do we keep track of that time?
Well, Claude, there are 2 ways I can think of. The first would be using an ordinary stopwatch. Set it for 5 minutes and then watch. I like to use my smartphone. My smartphone has an app on it that has a timer. I can set that timer for 5 minutes and then I can watch as the time expires.
Okay. Anything else we need?
Well, you also need to make sure that everything in the tank is completely sealed. So in addition to this opening, we need to make sure that the top openings are completely sealed. We can use an ordinary sealant to do that, or if we want to remove those openings later, we might want to use a non-tacky sealant. Also, the boots and openings around the tank might need to be sealed. We can use a wrap material and place the wrap material over those holes, or if necessary, we could use ordinary duct tape in the plant that sticks well to concrete and can be used to seal the openings. What we want to make sure of is that we have everything we need in place when we're doing the test.
Okay, so we have all our equipment assembled, everything is sealed, we have our safety equipment on. What's the last thing we need to do before we get started on this test?
Well, Claude, we also need to make sure that the tank is sufficient in strength to withstand the forces being applied during the test. So we need to make sure that the tank has enough age on it to withstand that. As we go around the tank and we look at the tank, we also want to make sure that as we're looking at the tank, we're making sure that there aren't any imperfections. One of the things we want to look at in specific is how well the joint is. Is it tight and is it sealed? Do you see any sealant imperfections? We also want to look at the tank to make sure there are no cracks or holes or voids that didn't get sealed yet. It's very important at this point to make sure that all these things are done so that we have an accurate test when we start this process.
Okay. So we just want to make sure that we do a good, thorough visual inspection of the tank before we get started so we don't have any false starts, so to speak.
That is correct, Claude.
Okay, what about the tank's foundation during the test?
Well, Claude, if this test is going to be for structural integrity, you would want to make sure that the tank itself is sitting on a bed of sand so that the weight of the tank could be equally distributed uniformly over that sand. For this particular test, the tank is sitting on dunnage, as you can see right here. The value of this for us is that we can still hear any vacuum leaks on the floor.
Oh. Okay, well, it seems like we've done our visual inspection. Everything looks good. Are we ready to get started?
Let's go over to the vacuum generator and get this test started. So Claude, at this point, what we're going to do is we're going to turn on the air. We're going to open up the air to the PVC so that we can start to draw the air out of the tank. This part of the test is quite noisy, so after I start this test, we will walk away from the equipment.
Okay.
Claude, at this point, we have achieved the vacuum level that we want. The gauges are reading just about 4.4 inches of mercury. So what I did is I shut the air off to the PVC first, then I shut the air off to the air line that goes to the compressor. At this point, we wait enough time to allow the tank to settle so that the gaskets are well sealed, that any other sealants are compressed, and that the tank is ready to be sealed. Once we allow that amount of time to pass, then we can start the test, the timed part of the test. Let's go over right now and look at the gauges.
Okay.
Claude, as I look at these gauges right now, the gauges are very settled and they're not moving. So at this point, the tank is very sealed and the air pressure inside is staying consistent. So at this point, we would start the timed test.
Okay.
I'll use my phone to record 5 minutes, and then we'll see what happens after 5 minutes.
Okay.
Claude, the 5 minutes has expired. Let's look at the gauges. The gauges appear to still be reading 4.4, so it looks like we have a successful test.
Great. Now, what about the documentation during this test?
Well, to document this test, the first thing you want to make sure you do is record the information of the tank. When was the tank manufactured? What is the size of the tank? If it's a specific tank off of a specific form, you want to make sure that you document the form it came off of. Also document what the test is being ran to, in this particular case, ASTM C1227. Okay. You would also want to make sure that you record the beginning pressure that was noticed. You would also want to record the final pressure that was seen after the 5 minutes.
All right, well, we were fortunate enough to have a successful test, but what if we were losing pressure? What's the first things you would look at?
Well, Claude, the first things I would look at is if there is a leak in the tank, I'm going to check the equipment first, make sure that there isn't a leak in the equipment. The second thing that happens most often is a leak in the risers. I will check those next. After I've checked those two more obvious things, I'll look at the tank. I like to look, listen, and feel for a leak. So as we look at the tank, we'll look and listen and feel for any leaks. Running your hand along the tank allows you to feel for any vacuum loss that might be pulling air into the tank.
All right, Sam, so let's say I'm running my hand along here, along this joint, and I can feel air being sucked in right here. What would you suggest doing there?
Claude, for a leak at the joint, I would recommend a modified polyurethane sealant that's a caulk material. You would apply that to the joint while it's under vacuum and allow that vacuum to pull that sealant into the tank to make a seal.
Okay. And then what about in the concrete itself? Like, let's say there was a little hole here or something that was drawing air in. What could we do in this case?
Well, for the surface of the concrete, it's good to take a cementitious slurry, mix it up, spread that cementitious slurry on the concrete again while it's under vacuum so that you're able to pull that slurry into the tank and seal that crack.
At what point should the tank not be repaired?
Well, Claude, if the tank cannot hold a vacuum at all, regardless of the repairs you've made, obviously that tank does not pass the test. It should not be repaired. But also if the tank has a structural crack or some other major failure, that is also a reason that the tank should not be allowed to pass this test or be repaired for a test.
So at that point, the tank should be disassembled, marked as failed, and then start with another tank.
That is correct, Claude.
So Sam, what if this vacuum pressure were to somehow cause some structural issues with the tank? How would you see that?
Well, Claude, if there was a structural failure with this tank, we might see some cracking along the walls or along the roof line. In a one compartment tank that has a top seam, we might see that crack along the floor. In a two compartment tank, we might see what's called a smiley face that emanates from one corner, goes around to the bottom and comes up the other side.
But that's pretty unlikely to happen, isn't it, during just a water tightness test?
It is very unlikely at this pressure, Claude, that you would have a structural failure.
Okay. Well, looks like we've had a good test. What's the last thing we need to do?
Well, Claude, the last thing we need to do is release the air and take the equipment off the tank.
Okay.
At this point, due to the noise induced, we have already released the air inside the tank. Even at this point, it's still unsafe to get on top of the tank or even inside the tank due to the pressures that were exerted. At this point, we'll start by disassembling the equipment. As I remove this hose clamp, it's a good time to just reiterate that as you're removing the equipment from the tank, remember to clean everything and make it ready for the next vacuum test.
Okay. Well, what would you say, Sam, are the most important things to remember when you're doing a vacuum test?
Well, Claude, one of the most important things to remember is consistency. It's very important to have a consistent process, a process that's documented, having all your equipment ready, having your people trained. You also need to make sure that you have a place to do this, that it's always done in the same place in the same manner so that it can always be done in a consistent way.
Okay. Well, Sam, thank you very much for guiding us through this. I very much appreciate it.
Thank you, Claude.
Okay, so 3 important points to remember. Number 1, have your test done somewhere where you can hear the leaks if there are any. Try to keep your tank away from noisy areas. Number 2, ASTM C1227 requires that you hold 4 inches for 5 minutes without any measurable drop. In order to see if it's dropping or not, you really need a gauge that is graduated from 0 to 10 so you can see that drop. Number 3, make sure you document this procedure in your plant quality control manual, and that way that will ensure that the test is done consistently no matter who's doing it. For more information on vacuum testing or anything else related to precast manufacturing, please contact NPCA or go to our website at precast.org. That's it for today, and thanks for watching.